Hola grade 12s. In today's lesson we're going to be looking at differential calculus. We're going to be focusing on grade 12 questions, specifically the cubic functions. With that being said, let's witness the func. Yes. So we have question 9. It says the graph of f of x is equals to 2x cubed plus 3x squared minus 12x is sketched below. A and B are the turning points of f. C 2:4 is a point on f, right? As we can see here, no, as we can see it here, right? So 9.1 says determine the coordinates of A and B, right? And you already know if we are to calculate the coordinates of A and B, the first thing that we need to do is to derive the cubic function that we are given here. But then let's get to why we do that. So if I can just sketch here, I normally tell the grade 12s that, okay, the f prime x that we are talking about is actually the parabola here. So if the graph is starting from here below, then the parabola will start from above there and then it will be concave up like that, right? So here you will notice that the x-intercepts of what? The x-intercept of the parabola are actually in line with the x-intercept of, so it's not drawn perfectly, but then this is the point I'm trying to drive home. The x-intercepts here of f prime x are actually in line with the x-intercept of the turning points of the cubic function. So this is why always when we want the coordinates of the turning points, we turn to f prime x. Why? Because in getting f prime x, we can now equate f prime x to 0. Why do we equate it to 0? Because remember, these are the x-intercepts, and then we know for the x-intercept always our y is equals to 0, right? So remember, our f prime x now becomes the graph for the parabola, right? Now becomes the equation for the parabola. And then if we want to get the x-intercept of the parabola, we must equate to 0. Remember, because the x-intercept, our y is equal to 0. So in getting the x-intercept, after getting the x coordinates, which happens to be the x-intercept of the parabola here, what do? We then take the x-intercept, we go back to the original given cubic function, or the given cubic graph. Then we substitute the x coordinate to get the y coordinates of what? Of the cubic function, right? So we substitute back there to get the coordinates of the y coordinates of the cubic function. So we only use f prime x to get what? The x coordinates. We only use f prime x to get the coordinates. So that's the reason why we equate f prime x to 0, because it is the x-intercept here, right? And then again, another reason why we equate f prime x equal to 0 is if you can draw a line here. Remember, again, we have a name. We no longer call it the parabola here. We say it's a what? It's a gradient graph, right? So if you were to draw your tangents here, you will see that your tangents will be parallel to the x-axis. And then knowing our properties of straight lines, we know that if we have a horizontal line like this that is parallel to the x-axis, then its gradient must be equal to 0. Remember, we use f prime x to get the gradient. So in other words, this is the gradient graph. And then if we are to calculate the coordinates at the turning points, we know at turning point the gradient is equal to 0, because if you draw a tangent at the turning points or the stationary points, they will be parallel to the x-axis, and a line that is parallel to the x-axis always has its gradient being equal to what? To 0. So that's why every time when we are calculating the x coordinates of the turning points, we will equate our gradient graph to 0. Why? Because at stationary points the gradient is equal to 0, right? So I think we all get that. Now let's get to the calculation part. We have 9.2. It says determine the coordinates of A and B. So we already know what to do. So we're gonna have this one originally as it is, 2x squared cube then 3x square minus 12x. So it's 2x cubed plus 3x squared minus 12x. Then what are we going to do? We're going to derive that expression. Then now we have 6x squared plus 6x minus 12. But then we know we are calculating the coordinates of the turning points. So therefore our gradient needs to be equal to what? To 0. Because that's at stationary points, and at stationary points our gradient is what? 0. Then here, if you can check, we have a common factor of 6. That means we can divide everything out by 6. Then dividing everything out by 6, we are left with x squared plus x minus 2 equal to 0. Then what are we supposed to do here? We are supposed to factorize this one, right? So factorizing x squared plus x minus 2 equal to 0, we're going to have x plus 2 x minus 1 equal to 0. Then this is x equal to negative 2 or x equal to 1. And then if you can check there, we can all agree that A is on the second quadrant, and our in the second quadrant our our x is always negative, right? Our x's are negative, so we have negative here. And then B is in the fourth quadrant. That means our x's here are positive. We're going to have the 1 here. But then this is not all. We are supposed to get the coordinates, right? That means we are supposed to get the ordered pairs of A and B. What is left? We are supposed to get the y coordinates of A and also the y coordinate of B. So what do we do to get the y coordinates? Because we now have the x from using the equation f prime x, then we need to now take the x coordinates that we have, then we go back to the original, which is f of x, substitute it there and get what? The y coordinates. Let's do that. So now we're going to have this one originally as it is. We have 2x cubed plus 3x squared minus 12x. Now we're looking for the coordinates, for the y coordinates when f is equal to negative 2. So where there is x, I'm just going to put negative 2. And check carefully how I do that. So I put it inside the brackets, right? So that there is no mistakes, right? So punch that in your calculator. You are supposed to get something like 20. Then your coordinates for A are supposed to be negative 2 is to 20, like that. Now let's get the coordinates for B. For B, we're going to have, again, if we can write out our equation originally so that we see it, plus 3x squared minus 12x. Now we want the y coordinates when f is equal to 1. So where there is x, I'm just going to put 1, 1, 1. Then punch that in your calculator. You are supposed to get negative 7. Then what are your coordinates for B? Positive 1 to negative 7, right? And if you can check here from your sketch, you can see that it makes sense. It makes sense that your B here would be 1 to negative 7, the negatives here, and then it makes sense that your A will be negative 2 to 20, right? Nice. So when you find your answers, you should always go back to the sketch to check if they make sense, right? At times, maybe you would have missed the sign. Then from checking your sketch, you know that maybe there is a mistake that you did. Then 9.2, for which values of x will f be concave up? So whenever we are talking concavity, we need to know that here we are talking the second derivative, right? The second derivative. So we must check the second derivative. Then first of all, before we can determine for which values is this concave up, we need to first find what? The point of inflection. So what is the point of inflection? In simple term, we can say the point of inflection is a point whereby we have a change in concavity. So you find your graph, maybe it was concave down, then at the point of inflection, that's where you have a transition from being concave down to concave up. So a point of inflection would be, in simple terms, a point whereby we have a transition of concavity, right? So we cannot determine what values of x will it be concave up or down if we don't have the point of inflection, right? So it can either be concave up after or before the point of inflection. So the first thing that we need to do here is calculate the point of inflection. So how are we going to do that? Remember, we already have the first derivative, right? So it's 6x squared plus 6x minus 12. So the second derivative will be to derive the first derivative, right? So deriving this one is 12x, then we have plus 6. Then what are we supposed to do to find the point of inflection? We must take this one and equate it to what? To 0. So we have f prime x equal to what? To 0. So always note that when we are looking for the point of inflection, we equate the second derivative to 0, right? So what do we have now? We have 12x plus 6 equal to 0. Then 12x is equals to negative 6 divided by 12, x is equals to negative half, right? Like that. That's not the only way though. Others could have easily gotten it from using this one, right? 3a, whereby you need to use the original formula, right? You need to use the original cubic function. So what do we have for b in the cubic function? We have 3, right? So we could have substituted 3 here. Then what do we have for a? We have 2. So if you can check that, negative 3 divided, so this is 3 here, yes. So negative 3 divided by 6, still it was gonna give you a negative half, right? And still someone else could have said, oh, I already have the coordinates here, which is negative 2, and then I have 1 here. They could have just got the midpoint of the x coordinates. So they could have just said negative 2 plus 1 divided by 2, meaning they're getting they're getting the midpoint of the x coordinates. So negative 2 plus 1 is going to give you negative 1 over 2. So there were 3 ways to kill a cat here. You could have gotten your point of inflection using 3 different ways, right? So but then the point is the point of inflection is negative 1 over 2, which by prediction it would be somewhere here, right? By prediction, your point of inflection would be somewhere here where you have a negative half. Now we want to know for which values will it be concave up, right? So what is concave up? Concave up, that's where we have a minimum value, right? So concave up is something like this. Then concave down, it's something like this, right? So concave up is this. So where is it concave up? Is it before or after the point of inflection? So you would realize that it's to the right. So it starts being concave up after the point of inflection. Remember, the point of inflection is not concave up, it's not concave down. This is just the point of transition, right? Then here, all the way here, it was concave down. Then starting from this point, after this point, the point of inflection, we have it being concave up. So how are we going to write that one? We're going to say for the values of where x, so for 9.2, we're going to have, so for 9.2, we're going to have when x is greater than negative 1 over 2. So that's where we have this graph being what? Being concave up, right? That's where we have it being concave up. Then they say now 9.3, determine the equation of the tangent to f, right? Determine the equation of the tangent to f. You will know that the tangent is what is a straight line. Always the tangent is a straight line. By definition, what is a tangent? A tangent is a straight line that touches the curve at only one point, right? So we know if it is a straight line, it should follow this. It should follow the general formula y is equals to mx plus c. Now we already know in order to get an equation of a straight line, there are two things that we need. We only need what? The gradient, and we need what? The y-intercept, right? But then here we are given what? The coordinates. 2:4. And then we can get the gradient from f prime x. Remember, f prime x is the gradient formula. And then what are we supposed to do here? We are supposed to get the gradient where, at what point? At 2, right? So that means if we had to draw a tangent here, it would be a tangent that crosses here, touches here, then we have to get the gradient at what? At this point, at x is equal to 2. So how do you get the gradient at x is equal to 2? You just come at the gradient formula, then you substitute 2 here. The answer that you got, that's the what? The gradient at that point. So we need to get the gradient at this point, which is x is equal to 2. Now let's do that one. So I'm just gonna erase here. So now we're looking for, remember we already have the gradient formula. It's 6x squared plus 6x minus 12. Now we want the gradient at what point? We want the gradient at point x is equals to 2. So we're just gonna substitute 2 here, right? So where this x, I'm gonna substitute 2. Why? Because I'm looking for the gradient at that point. So if you substitute there, you're gonna have 24. Now I know that my f prime 2 is the same as the gradient, right? At that point. So it's the same as the gradient at point 2, right? At x is equals to 2. So now that I have that one, I know the equation. The equation to get the straight line, the equation of a straight line from your formula sheet is like this. Now that you are given coordinates, it's easy. Your coordinates, you substitute them here, right? So you have all the coordinates, your x and y coordinates, they are given at c, 2:4. So you will know that they never give you anything that you won't use. So every information is valuable. Then 24 here, x minus 2. Then you do your math. 24x, then 24 times negative 2, it's gonna be negative 48. Then transpose that 4 plus 4. Then now you have y is equals to 24x minus 44. That's the equation of your tangent, right? Nice one.